Hey guys, and welcome back to the Turdford Show. All right, so in this video, what I actually want to do is take a look specifically at not just one-dimensional motion, but I want to take a look at the difference between what we know as velocity and speed. What is the difference between those two, and how do we calculate them? All right, so essentially the equation for velocity, when I write that out, is that velocity is equal to, and I use the lowercase v, it's equal to a change in displacement over a change in time. And I'll admit I'm the world's worst of just writing x over t as opposed to delta x over delta t. And I'll explain that in a second. I also need to do one more thing. Whenever you just take basically a displacement divided by a time, that's also specifically an average velocity. So that's why you see me use that little notation that I've put up above the V in this case. All right, so that's an average velocity. Now notice I kept saying it is what? A change in displacement. So you got to make sure you understand what that word means. Now, speed, I'm not even going to write any abbreviations for speed because I use it so very little. I'm just going to actually write it out like this. In physics, it's very rare we actually want speed. So I'm just going to write it's speed over time is all it is. And there is a very, very big difference that you need to kind of keep in mind. Velocity is a vector. And I don't know if you know what those words mean yet. Speed is a scalar. But what it means is this. A scalar means that it just has a magnitude. Scalars just have magnitude. Like you've probably heard 50 miles per hour before, but you don't have any idea of one more piece of information. That's where a vector is different. Vectors have a magnitude and a direction in there. So that's the difference, primary difference between what we would refer to as speed and velocity. So now here's the deal. I need you to understand what this word displacement is, and then you'll be pretty good to go. So let's say, for example, you've got a football field here. Let's say there is the goal line of the football field, and you got some dude standing there, dudette standing on the goal line. So here we go. Out here we got the 50-yard line, and there's the 50-yard line. And let's just say that this individual decides to, I don't know, let's say they run to the 50-yard line, and maybe they run back to, let's say the 30-yard line, and then run back once more, kind of doing what's kind of like a suicide drill, to the 40-yard line. So if you can understand this example, you'll be able to understand the difference between distance and displacement. And that's what's the most important part of this. So displacement is nothing but a comparison of your, so it's, I'm going to write this, a diff in your, let's say your stop and start positions. So in other words, it doesn't care where you've been. All displacement is interested in, where did I start? Well, I started at, let's just say X initial. I started at the goal line, so I'm going to make that 0. So now the question is just this. Where is X final? Well, X final is at the 40-yard line. Well, then your displacement, your change in displacement is nothing but 40 yards. Well, wait a minute. You didn't talk about all the running over and back and running. That's right, because in terms of displacement, we don't actually care about any of this stuff. Not only this guy could have ran completely crooked as he ran. Here, the guy could have actually ran like over to here, back up to here, something. There's a bear chasing him. It doesn't matter. All we were interested in is where did he start, X initial, and compare that to X final, where did he stop. So that's all displacement is. Now, if you're asked to do a speed problem, that's when you actually need to know your distance. So you need to know how far did this individual run total. Well, they ran 50 yards, and then let's say they ran back to the 30. So if we start doing a little tracking here, that means they they ran 50 yards over, they ran 20 yards backwards, and then they ran 10 more yards forwards. Again, the directions themselves aren't important. We're just looking overall. So 50, 20, 10. So we had a distance in this problem of 80 yards. So if I was asked to do a velocity question, let's say it took this guy 10 seconds to do all this. He's incredible. So if I was asked to find his velocity, I would take 40 yards and divide by 10 seconds, and we'd have 4 yards per second. Whereas I come back over and did speed, we would go 80 divided by 10 and have 8 yards per second. So there is your difference. I'll give you one more little trick, and this is where sometimes people will try and get you, or a teacher may try and get you on the difference between like speed and velocity. Excuse me. They'll give you this as like a good example. Say somebody runs, let's use meters and get more physicsy with it, 4 meters this way, and let's say they then run 3 meters this way. And they did this in a time of 10 seconds. So what would be this individual's velocity? Well, their velocity or average velocity would be nothing but simply what? A comparison. Where did they start compared to where did they finish? Well, you should know that's kind of what we got here. Oh, wait a minute. Oh, the math teachers love this. A 3, 4, 5 triangle. So that means this would just be 5 over 10, 5 meters, 10 seconds, average velocity of 0.5 meters per second. And then where if I were asked speed of this individual, I would actually end up doing his total distance, 7 meters over 10 seconds, and it would be 0.7 meters per second. But anyway, that should have you a pretty good basis of the difference in speed and velocity, also about what a vector, a little basic idea of a vector, and we'll talk about more of that in other videos. Anyway, thanks for watching, guys. I'll catch you in the next one.